velocity of the, you can do it, you can do it, you can do it. You can take that rotational motion about any point. This is 2v. Similar, the similar condition. So let me take this a disk now. Radius r, mass m. So what is the velocity of the upper and lower belt? Two v and v. So I want first intensity center, then the velocity of point P. Anything, or let me take no this side. I want the velocity of point P, velocity of center of mass. Find VC, VP, and kinetic energy of the disk. So shall we call this the upper belt? This is the lower belt. Okay, no. So what shall you do? So what is the basic concept? Draw a velocity vector, draw a line joining the head of velocity vector, draw a line joining the tail of velocity vector, where they intersect, that is the instant center. So from sir, how you can think like that? I just took the rigid body, some disk rotating, not only disk, any rigid body. Then what I noticed is this particular thing, it is rotating about its center, I know. Then when I look at the geometry, I got that condition. So this condition is what I'm applying here. I'm not bringing new thing. The rotation of rigid body, you might have noticed this. Of course, we don't notice. That's why we are stressing it separately. Actually, if you have noticed, there's no need to discuss this topic. See, that's what science is all about, observation. Huh? Yes, belt seems to rotate means at that instant the velocity of belt will be there like that only. Okay, come for this one. So what is the basic thing? This is 2v. So where is the center of mass? Center of mass is here, no? Exactly at the midpoint. This is R, this is R. Now what shall I do? I'm going to draw a line joining the velocity vectors. This is the velocity vector 2v and this is v. So this is the center C, and this is the instantaneous center about which they are going to rotate. High C, I should write, and this is the omega. So what is the distance now? So let me call this is y. And then what is the equation? 2v is equal to r plus y into omega. Then what is v? V should be equal to r minus y omega. So this distance will become r minus y. Divide these two. So 2 is equal to r plus y by r minus y. So 2r minus 2y is equal to r plus y. Y shall I write r by 3? Where the instant center will be below the center of mass. So instant center must be on the rigid body. Need not know. It can lie on the rigid body. It can lie outside the rigid body. We don't know omega. So I'll substitute value of y. I'll get the omega. But what we know only velocity of upper and lower belts. So how to bring the omega? I'll take help of any one equation. V equal to r minus y into omega. What is y? R by 3. Omega equal to 3v by 2r. Yes, this is the angular velocity with which the rigid body is rotating. Okay, but we wanted velocity of what? Point P, all other things. I'll push it, this one here. Okay, now you got omega. After getting omega, now I want the velocity of point P. Where our instant center is? Instant center is somewhere here, no? I'll put star mark. Not center of mass. There's the instantaneous center. Then can we calculate the velocity of point P? Yes, we know all the information. Here, this is R. So what is the velocity of point P? How to locate? It will be like this. What is the velocity of center of mass? Will be like this. This is the instantaneous center. Don't use any other symbol. IC only, we have to write it. And this is that Y. So this is R. So how to calculate that? What is small r should be equal to? Small r should be equal to root of R square plus Y square. What is Y equal to? R by 3 whole square. So this should be equal to R by 3 root 10. So now what is the speed of point P, which is equal to how much? R into omega. What is small r? R by 3 root 10. What is omega? 3v by 2r. Root 10 by 2 into v. Okay, this is the speed of that point P. Now I want the velocity of center of mass. I don't know. That what you can write it as? Y into omega. What is y is equal to? R by 3. Omega is 3v by 2r. This is the speed of the center of mass. Then can we calculate total kinetic energy? Translational plus rotational. What is the translational kinetic energy? Mass of the disk into velocity of center of mass plus moment of inertia. So if you are getting confusion, I'll write high O. What is O? O is the center of mass. Some of you are getting confusion. I'll write O. I think it's substitute, you'll get it. So just if they give velocity of any 2 points on a rigid body, can you predict the angular velocity? Yes. Now sir, like a practically about what point the disk is rotating. What is this K? Kinetic energy of the disk. No. Practically about omega. Omega will be about O only. The diagram what we see practical will be of this kind. Center of mass will be moving. Omega naught. So if you just know these two quantities, this velocity of the upper and lower belt, you can predict all other things. Velocity of center of mass, angular velocity. But sir, like you wrote omega about instant center. Then again you are writing about O. I think if you stand at instant center, you feel all points are rotating about instant center. You stand on the ground, you feel all points are rotating about center of mass and center of mass moving towards right. So who is drawing this diagram? Who is drawing this diagram? Person on the ground. So getting the overall picture. So tomorrow what happened? we'll explore few more problems. They just gave this one. We'll see this particular motion with respect to rod, cone, different types of rigid body. We took only rolling bodies. We'll take the different rigid